Hello, this is another chapter, or sorry, another lecture in chapter 1. This is the lecture on the appendix of chapter 1, which is a math review. And there is some math required in economics, both microeconomics and macroeconomics. And the math we use quite a bit is graphical. We have some equations, percent changes, but mostly our math is graphical. And you'll find there's two different kinds of graphs in your textbook. First of all, you have what's called descriptive graphs. And these are in the form of maybe bar graphs, pie charts, time series, things like that. And an example of a time series is right here. Here we have a looks real average income by percentiles. Percentiles is how they break down the population, and they could break it down into like groups of 20%, the poorest 20, the richest 20, something like that. And when this one broke it down was the 90% here. So if I push it up, you would have 90% right there, and the bottom 90%, you can see the real income from 1980 to 2015 has barely increased at all. It's pretty flat, and right here it says it's gone up a fraction of a percent. So pretty much the real income for the vast majority of Americans, and this is for America. And this shows that most of the gains have gone to the richest people. The top 1% looks like they increased their income by maybe a little over 100%. And if you go to the richest 0.01%, their income's gone up dramatically. And the number is 322%. So it shows that most of the gains out there for the average American has been pretty stagnant, but most of the wealth has gone again to the richest 0.01%. This graph does not present any kind of analytical analysis. It simply presents information. And that is what your descriptive graphs do. They simply present information. So going back. So we have these graphs in their textbook, and I'll show you some in lectures as well. And again, they just present information. The ones that are used to analyze cause and effect are known as analytical graphs. These ones show relationships between variables. So when you have a function shows the relationship between a dependent variable and one or more independent variables. So a function is what analytical graphs show. They show relationships, and a function is a relationship. In a math class, you might have seen this in the way they talk about functions. They have y is equal to f of x. What that means in plain English is that we're not quite plain English, but we're getting there. Y is a function of x, which means in plain English, y depends on x. And so when you see y is equal to f of x, all they're saying is that the y variable is affected by the x variable. And so since y is affected by x, we call y the dependent variable because it's dependent on x. And x is not dependent on anything in this equation, in this function, so the x is said to be an independent variable. Moving along. Then your relationships functions can be either direct or they can be indirect. Direct also means positive, and it means when x increases, that's going to cause y to go up, and when x goes down, it causes y to go down. So they move in the same direction. An example would be profit and investment. And so it says that investment's a y variable. And so what it means that if profit increases, moving arrow is showing up, that's an increase. That's going to cause, an arrow going that way means it's going to cause that investment also increases. And so investment is dependent on profit. If profit goes up, that will lead to higher investment. Now, in economics, when we see a relationship like that, either positive or negative, we like to know maybe what's going on, but we like to maybe go further and find out what's going on here. And so why would higher profit lead to higher investment? Well, two reasons come to mind. One is that more profit for a company means they have the means for more investment, first of all. And also if profit is going up, that probably means sales are good, which means they probably want to invest in more capacity so they can sell more and make more profit. Likewise, when profit goes down, so if profit goes down, that's going to cause investment to go down. Again, lower profit means you have less means for investment. It also probably means your sales are not very good, which means it's probably not the right time to do more investment. And so we have lots and lots of positive direct relationships in economics. And we have also lots and lots and lots of indirect negative relationships. And here, when x increases, it causes y not to increase but to decrease. And when x increases, y increases. So now the two variables move in opposite directions. And down here we have interest rates and we have stock prices. So interest rates is the dependent variable. And so interest rates is the cost of getting loans. And if they go down, that's good for business. It makes it cheaper to borrow money, and therefore it's more likely to lead to business to invest more, which probably means more sales, more profit, and therefore the stock market is going to like that. And that's pretty much how it works. Whenever the Federal Reserve, it's a lousy arrow, whenever the Federal Reserve announces they're going to drive down interest rates, that means that stock market tends to go up. And likewise, if the Federal Reserve announces interest rates going up, that tends to drive down stock prices. So they tend to move in opposite directions. Now, the types of functions we're going to use in this class can be either linear or nonlinear. The good news is that the ones we'll spend most of the time on in terms of any kind of equations will be linear. And that's nice because linear functions are the easiest functions to use mathematically. And what's nice about linear functions is that the way that x affects y never changes. So a has a constant impact on y, which means that if you graph it, you get a line, which means it's a linear function. Typically in a math class, you would see it written this way, where y is equal to mx plus b. It could be y is equal to a plus bx sometimes. It doesn't really matter. Whatever is tied to x, if it's called an m or a b, whatever, that's always going to be the slope. And the one by itself, the constant, is always going to be what they call in a math class the y-intercept. So here again, y is the dependent variable, x is the independent variable. So x is the thing on the right side tied to that m. Y is all by itself because y is going to be affected by whatever this equation is. And then your parameters are your constants. And so your b is going to be a constant. And that doesn't tell us much information about x and y. In fact, it tells us nothing about x and y. It's simply we have to start somewhere, and so b tells us where we start. So essentially what b is that if x is nothing, 0, where does y start from? Y could be 0, y could be a positive number, y could be a negative number. So b just tells us a starting point. Really nothing interesting there. What really matters is this slope m. That is the key. That tells us the way that x affects y. So it tells us the change in y when x increases by 1 unit. So you write it this way, where you have a change in y over the change in x. And we use the sign delta sign. It's like a triangle. It's a Greek symbol, delta, and that stands for change in. So m is equal to the change in the y variable over the change in the x variable. And that's always going to be the case. And the way that x affects y always stays the same, so that's going to be a constant number. So for example, I just made up some data here. It's getting close to 10 minutes, so what I'll do is I'll just show you the first graph. We'll end the lecture here, and then I'll come back with a part 2 lecture on the math review, and we'll finish that off. So let me just get the first one in here. What I did, I just made up some data for, say, a potential class or a imaginary class, And here we have different days of attendance. So these will be days that students come to class. And these are the points they get maybe on a quiz after those 3 days. And so we have a positive relationship here because when you have more days, your points are going up. So mathematically, we can graph this data, and then we can also get the equation of this data. And so here we have our B, our variable, not a variable. We have B, which is our y-intercept, and that is 0 days. So if you come to class 0 days, you will get 10 points. And I'll put that right there. I've already put on the numbers here for our number lines. We have points going vertically, and we have days going horizontally. Typically, in a math procedure, you would put the y variable, the dependent variable, on the vertical axis, which tends to be called the y variable, the y-axis, and then we put the x variable on the horizontal axis, which tends to be known as the x variable. And then just plotting this by hand, kind of eyeballing it here. So here we have 15 points, and that's 1 day. So I've drawn some reference lines like that. And then we have 2 days to come to class, you get 20 points. And 3 days, we'll get 30 points. Yeah. And if I get a ruler out, try to make it a little nicer. That's y-intercept. We start at 10, and then kind of draw a line for those points. If I kind of miss them, I just make my dots a little bigger. Yeah, it's good enough. And that's where we start from, 10. And then this is the increase here, so it's a positive relationship. And I guess it's going on 12 minutes now, so what I'll do is I'll stop here, and I'll come back and I'll talk more about the equation of the line for Class A.